Hello, ladies and gentlemen. Today we're going to be looking at investigating and using formulas for finding distance and midpoint. Let's start first with our midpoint formula. So if we look at here, we have point A and we have point B. So we're going to use our x-coordinates from A and B divided by 2 to get our x-coordinate for our midpoint M. Then we take our y-coordinates from A and B, add them, divide by 2 to get our y-coordinate for our midpoint M. Kind of think of it as almost like an average between those 2 points to find halfway between it. Let's look at an example. So we have line segment EF, and it has the endpoints 7, 5, and 2, -4. What are the coordinates of its midpoint M? So with this, let's use our formula. So we know that we're going to have x1 plus x2 divided by 2. And we have y1 plus y2 divided by 2. So we can go through and label our points. We'll say 7 is going to be my x1. That means 5 has to be my y1. If 2 then will be my x2, -4 will have to be my y2. We can substitute those values in. So we get 7 plus 2 divided by 2. And then we have 5 plus -4 divided by 2, which is going to give us 9/2 for our x-coordinate and 1/2 for our y-coordinate. So the ordered pair for our midpoint is going to be 9/2, 1/2. Try this one on your own. Now let's find an endpoint. So when you know the midpoint and an endpoint of a segment, you can use the midpoint formula to find the other point. So if we look at this example, the midpoint of line segment CD is -2, 1, and one of the endpoints is -5, 7. We want to know what are the coordinates of endpoint D. So if we take our formula that we have, let's start with our x. So we know it's x1 plus x2 divided by 2 is going to be equal to our x-coordinate for our midpoint, which is -2. So let's set that equal to -2. If we take our x-coordinate for point C, we know that is -5. So let's substitute that in for one of our x values. Plus, erase that. Okay, don't want to confuse anybody with my poor writing. So we have -5 plus x2 divided by 2 equals to -2. Now we just need to solve this two-step equation. So we multiply by -2 by 2, so we get -5 plus x2 is equal to -4. Add 5 to both sides. We know our x-coordinate for point D will be equal to +1. So we go through and do the same thing for y. We're going to take y1 plus y2 all over 2 equals to 1. Substitute our y-coordinate for point C, which was 7. So 7 plus y2 divided by 2 is equal to 1. Multiply by 2, we get 7 plus y2 equals to 2. Subtract 7 from both sides, we get our y-coordinate to equal -5. So we know that our point D is going to have the coordinates of 1, -5. Alright, try this problem on your own. Now we have our distance formula. So our distance formula, you can see, is the square root of x2 minus x1 squared plus y2 minus y1 squared. If we look at this picture, we see down here our 2 points, and we want to find the distance between them. The shortest distance between 2 points is going to be a straight line. So if we look at this example, we have to find the distance between point U, -7, 5, and B, 4, -3, and we're going to round it to the nearest tenth. So using our formula, we're going to substitute in. So we know distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, think back to our slope formula. It really doesn't matter which point you substitute in for x1 or x2. I'm just going to say that since this one comes first, this will be my x1, so this is my y1, this is my x2, so this will be my y2. But if we did it backwards, it would still give us the same answer. So if I substitute those values in, I'm going to get 4 minus negative 7 squared plus negative 3 minus 5 squared, and then take the square root of that. So we know inside 4 minus negative 7 is going to be 11 squared plus negative 3 minus 5 is negative 8 squared, square root. So still simplifying, we know 11 squared is 121 plus 64, and then we can take this, we can go through and take the square root of that. Alright, so next if we go through, add those two numbers, we get the square root of 185. We know 185 is not a perfect square, and there's actually no perfect squares that we can substitute in there except 1. So we're just going to take the square root of 185, which is going to be approximately 13.6, and it said to round to the nearest tenth, so 13.6 is going to be our distance. Here's another try it problem. Make sure you complete all the 3 try it problems and bring them into class tomorrow to go over.